Hello everyone, welcome to this lecture video. In the operating system process scheduling synchronization, we have the CPU scheduling, multi-level queue scheduling, and multi-level feedback queue scheduling. We are going to discuss about this in the topic. We have multi-level queue scheduling and multi-level feedback queue scheduling. Let's start with multi-level queue scheduling. The processes are easily classified into different groups. A common division made up between for foreground interactive process and background batch process. There are two types of process have different process response time requirements, and so many have different scheduling needs. So in addition to foreground process may have priority and over background process here. So multi-level queue scheduling will have the things based upon this. Multi-level queue scheduling will have the process are permanently assigned to one queue, so it owns scheduling. So for example, separate queues might be used for foreground and background process. So foreground queue might be scheduled by an RR algorithm, while the background algorithm scheduled by a FCFS algorithm, which has been we discussed in the previous lecture video. So multi-level queue scheduling algorithm partitions the ready queues into several separate queues. So let's look on an example of multi-level queue scheduling algorithm with 5 queues listed below in order of priority: system process, interactive editing process, batch process, and student process. Let's have the system process and interactive process. We can see what is system process, interactive process, and interactive editing process, and batch process and student process here. So here multi-level processing, highest priority and lowest priority will be given for multi-level queue scheduling. Then have the each queue will be absolute priority over low priority queues. So no process in the batch queue, for example, could run endless. So the queues for the system process are all empty. So time slice is a major things we are discussed in the time slice concept. So foreground queue RR scheduling, while background queue receives 20% of CPU, gives to the process and FCFS physics. So multi-level feedback queue scheduling is a kind of things used for process. Do not move from one queue to another. The process will not to from another. The setup advantage of low scheduling over it, but it is inflexible one. So the multi-level feedback queue scheduling algorithm contrast allows a process to move between the queues. So idea is to separate process according to the characteristics of their CPU burst. It is a process use too much of CPU time, it will move to a lower priority. This queues leaves an input-output bound and interactive process in the higher priority queues. In addition, a process that waits too long in a lower priority queue may be moved to a higher priority queue. The form of aging prevents starvation here. So for example, the consider multiple feedback. The schedule first all process only when Q0 is empty will you execute process in the Q1. Similarly, process Q2 will be executed only if Qs and 1 are empty. The process are arise for Q1 will be preempt process in Q2. So process in Q1 will turn be preempted by a process arriving for the Q0. So quantum equal to 8, quantum equal to 16, and if FCFS is a multi-level feedback queues. So here we can have the things quantum equal to 8, it will the quantum will be 6. FCFS will the multi-level feedback queues. So different levels of queues will be sent one by one. First queue will be in the queue order, it will follow the FIFO. So in this process we have the entering the ready queue is 0. The process queue will be given time is quantum of 8 millisecond. So for example, you have the quantum of 8 millisecond. If it does not finish with its time, it move to the tail of the queue. So the Q0 is empty, the process the Q1 is given the quantum of 16 millisecond. So previous example you have the 8 millisecond. So here the 60 milliseconds, if does not complete, it is permitted by and put into the Q2. So process in Q2 are run on a FCFS basis, but are run only when the Qs and zeros and 1 are empty. So we have the scheduling algorithm gives the highest priority to any process with a CPU burst of 8 milliseconds or less. Such a process will quickly get into the CPU. For example, you have the different CPU burst and get and IO burst process that need to more than 8. Example, FCFS long process ultimately sync to the Q2 and served in the FCFS order with any CPU cycle left over from Qs and 1s. So in general, multi-level feedback queue schedule is defined by the following parameters: the number of queues, scheduling algorithm for each queues, method used to determine when to upgrade a process and higher priority queue. This method used to determine when to demote a process to a lower priority queue. The method used to determine which queue process will be entered the process needs a service. So these are about the things we have discussed in the multi-level feedback queue. Thanks for watching multi-level feedback queue. Hope all understand what is multi-level feedback queues in the CPU scheduling algorithm in the operating system. Thanks for watching. Thank you all.